All right, so for LSTM is quite the same thing, right? The only thing is that where we see RNN, we change it to LSTM. Okay, so I just copied the same code, right? This one is just the same code that we have above there, right? The callback list is just the same thing, so I copied it from here. Okay, I mean, you've already written it, so you don't need to write it again. Let's go down. Where is the callback list? This one. I just copied the same callback list. So instead of naming it as callback underscore list RNN, I just name it as callback underscore list LSTM. Okay, that's the only change that I did. Okay, that's the only change that I did for that. And then I copied this one as well. So instead of model RNN, I use model LSTM, right? But first you need to define the architecture. Okay, you need to copy this architecture. So instead of here using say simple RNN, right, you change this simple RNN to LSTM. That's the only thing. And then you change the name as well. Okay, make sure that you change this name to LSTM, and that's it. That's the only change that you need to do, right? So I copied the same code, right, the same code, and I brought it down here, and I just change it. Okay, LSTM, model LSTM, right? Instead of RNN, I'm putting LSTM over there. That's it. That's the only difference. The code is just the same thing. Nothing else changes. All right. So I just run it, and that's it. The compile, everything, right? I just rename it, and that's it. That's the only thing that I did. So here, if you go and then see the performance, I mean, it's quite similar to the RNN. Okay, but I mean, there are certain situations where you will see this one a significant difference between this one, right? I think the title here, I need to change the title as well, right? I forgot to change the title, right? So here, make sure you change it to LSTM. Okay, LSTM. All right, make sure you change it to that, so that here, I mean, this one will change as well. Okay, but you can see the results are quite similar to the LSTM results. Okay, I mean to the RNN results. Okay, but there are certain situations where you will see that you find out that the LSTM is actually performing way better than the RNN. Okay, in this case they are performing quite similar, but there are certain situations where LSTM has proven quite a lot robust than the RNN. All right. I'm just also plotting the classification report and the confusion metrics just for reference to see how our model is doing. Okay, so you can see, as I said, you can mostly use the F1 score to see the overall performance, right? So for a model to be able to predict 0, right, we have around 59% of the F1 score, and then we have 61, right? So our model is more able to predict more of the ones than the the zeros, but the difference is not that much. I mean, just 2, right? The difference is not that much, so that's quite okay. That's quite okay. That's why you've seen the performance not being bad at all. Okay, and if you see the confusion metrics, right, there's still, it's telling you that. That's why I say that don't use just one performance metrics in measuring the performance of your your model. Okay, because when I come here and then I see the confusion metrics, I can see that around 29% of the time I'm able to predict the zeros as zeros. Okay, I'm able to predict zeros as zeros, and around around 20% of the time I'm making mistakes, right, predicting zeros as ones. That is very bad. And here you can see that around 30% of the time I'm able to predict ones as ones, right? And around 19% of the time I'm able to predict ones as zeros. So you see that most of the time I'm able to correctly predict ones, and that's why this one is telling us, it's giving us a higher value over here for the ones than the zeros, right? But you can see that I should be able to predict more of these zeros than making mistakes, right? Because the mistakes are too much. Okay, it's very close to the the correct predictions. Okay, so I can just go and then continuously increasing the complexity of the model to see how it is doing and all that. Okay, all those tracking things that we can do up there, right? So spend time to try to bring this one down, okay, by just playing around the model architecture. Okay, whether adding some dropouts or reducing some dropout, or everything that you can do. Okay, just try, spend time to just massage it to see how you can bring this one down. Okay, The last thing over here that I'm doing is to create a custom trait and then use it to try the model to see that it's working. Okay, so I have a test here which is saying that today is a sad day. I have another sentence saying that he was happy today, and then another one saying that not a good job. So now I'm going to pass in this kind of trait that someone has treated. Okay, so we have 3 different traits. Someone treated today is a sad day, someone treated he was happy today, someone treated not a good job. So I want to pass this one to our model to see if it's working or not. Right, and first we need to tokenize these things. Right, we need to tokenize. We cannot put these words into the model. We need to make sure that they are in the form of numbers. Right, so we tokenize and pad them respectively. Okay, we tokenize and pad them to be the same size or the same length as the length of the trees that we're using to build our model. All right, so once I do that, then I'm going to use the predict function over here. Okay, so I'm doing model rnn.predict. I'm predicting on the test data. Okay, so once I predict, remember here I've stored everything in s-test. Okay, so that's the words that I've created. The new words that I have, and I've stored it in s-test, and that's what I'm going to use over here. So once I do model.predict, and then I find, remember model.predict is just going to give me probabilities. Okay, so if the probability of the word, okay, the probability of the sentence is greater than 0.3, then I'm going to say that it's positive. If the probability is less than 0.3, then I'm going to say it's negative. Okay, you can play around these probabilities if you, as much as you want. Right? Sometimes if you give it very low, it's gonna make mistakes. If you give it very high, it's also gonna make mistakes. So just play around it to get the right values. In this case, I ended up getting 0.3 as the right value. All right, so for instance, if the sentence is say today is a Saturday, the probability that I got is 0.001, which is very, very less. Okay, which is very, very less. So in that case, it's going to be a negative. Okay, it's not greater than 0.3, so it's going to be a negative sentence. And of course, today is a sad day, it's a negative sentence. Okay, and this one is he was happy today. That's a positive sentence, and you can see the probability is 0.5 something. Okay, which is greater than 0.3, so that becomes a positive sentence. Okay, not a good job, the probability is 0.45. okay, 0.45. now you can see here, not a good job is a negative sentence, right? But here it's saying that it's positive because of the threshold that I've given. Okay, because of the threshold that I've given over here. So maybe I should increase this threshold a bit to maybe 0.5 or something like that. Okay, something like that, then I will be able to get the right one. So I intentionally left this one so that you get to know that you need to play around these numbers so that you get the right one. So instead of 0.3, I can put 0.5 over here so that this value will fall below the the threshold, and then this sentence will be tagged as negative. All right. Okay, so that's basically all that I want to show you in this notebook. You can see there are quite a lot of things to learn from this notebook, quite a lot of things over here. You're always going to need to refer to this notebook, right? Many times. All right, many times. All right, so I hope you've enjoyed this, and go through this notebook once alongside the video to get your hands on. Right, we have a project which is coming, which you're going to need most of the skills that you have seen so far in order to complete that project. So watch it one more time to get a better understanding of that. Okay. All right, so see you in the next tutorial. Have a nice day.